Thank you. Carbon efficiency. We hear this phrase all the time, but what does it actually mean and where does it apply? Well, it applies to biorefineries and paper pulp mills. These industries lack carbon efficiency because they don't use the whole tree. These industries take carbohydrates, which make up around 70% of woody biomass, and convert them into paper products and liquid fuels. However, they don't use lignin well. Lignin makes up around 25 to 30% of woody biomass, and it can be visualized as support beams holding a plant together. These industries waste millions of tons of lignin every year by burning it. And when you burn lignin, it's only worth around $40 a ton. However, if you convert lignin into a high-valued chemical, it can be worth up to $40,000 a ton. So we wanted to find a way to use lignin. We wanted to break lignin down selectively into high-valued chemicals. Now, other people have broken lignin down in the past, but not selectively. They break it down into hundreds or thousands of different chemicals. And when you break it down into so many pieces, it's nearly impossible to upgrade these into something of value. So we got to work in the lab, and we started working with model lignin compounds that we made ourselves. We studied the basic science of lignin breakdown, and we developed a metal catalyst that could selectively break down model lignin compounds. But we wanted to work with real woody biomass. So we went out to the Lafayette Municipal Waste Dump, we got some tree branches, milled them down into wood chips, and put these wood chips in our reactor. And we found that our catalyst could break down selectively 50% of the lignin in this biomass into two chemicals. This is selectivity that hasn't been seen before. Moreover, after we remove the lignin, the carbohydrates remain intact and can still be used for making products such as paper or cellulosic fuels. Now, these two molecules that we're making from the lignin, they represent a new green chemical feedstock. With little to no modification, they can be sold into a $1 billion specialty chemical market. They can also be converted into green polymers, and there are known processes to upgrade these into liquid fuel additives. Through this experience, I've been able to help found Sparrow Energy Incorporated, a startup company in Purdue Research Park, and raise $260,000 since January to bring this technology from a Purdue chemistry lab into a new green chemical factory of the future. We are pioneering a greener future by selectively breaking lignin down in woody biomass into high-value chemicals and improving carbon efficiency. Thank you.